Hello everyone, my name is Ade Manikanta, roll number 220 Today I will be walking through my implementation of assignment 11, which focuses on the security multi-part communication, specifically the SUM protocol. The goal of the assignment is to allow n particles to compute the sum of their private inputs without even revealing their individual secrets to each other. We use an additive secret sharing mechanism to make this happen. Let's dive right to the code. In this, now here we can see the class SMPC protocol. In this int construction, we pass in our participants dynamically. Noticing my variable names include my name Ade Manikanta 220 CA05 as specifically in our assignment requirement. We initialize the number of participation and criticality. We set our modulus to the power of 32. The 32-bit modulus ensures that all our method automatically loop around, effectively hiding the actual raw numbers. Secret sharing, let's see the phase 1 secret sharing. And next up the share secret function. This is how a participation divides their private input into sharing. For every other participation, we generate a random number using random dot rand int 1, 100. These random numbers are distributed as shared, but to ensure the summarization remains accurate, that participants calculate their own share by subtracting the sum of all those random numbers from their true secret. Finally, they appeal a modulo 2 power 32 to the results. That directionally of a shares is what gets disturbed. Partially some are reconstructed. Let's scroll down to line number 29. Here you can see the computer partial sum and reconstruction result. Once everyone has received their share from everyone else, they run compute partial sum. No one key known everyone else secret. They only have meaningless random shares, but each person sums up everything they receive, applies the modulo and computes a partial sum. Finally, reconstruction results takes all the participants' partial sums, adds them together under the same modulo, and outputs the final results. Run the interactive implementation. Scroll down into the main. At this line, instead of using hard code inputs, I will describe the main function to dynamically accept the number of participants, their names and their secret inputs. Intuitively, let's run this in the terminal and see it in action. Open terminal like Python 3. Simp Manikanta 2201 CA05.py. First, we initialize the environment. Let's input 4 for the number of particles. I'll enter them as Alliance with a secret of 42, Bob with 17, Charlie with 100, and David with 25. Bob with 17, Charlie with 100, David with 255. As we hit enter, the security protocol executes. Explain the output log. Here we can explain the output log in there. We scroll down, looking at the print logs. The expected sum is 4 on 4. Let's see how our protocol gets there securely. Phase 1, you can see Alliance gets here secret 42 generated completely random shares for Bob, Charlie and David, and calculates her own shares, which results in a massive number due to the modulation wraparound of a negative number. Phase 2, these shares are distributed over the network to the respective pairs. Phase 3, each participant aggregates their received number to create the partial sum. Notice how Bob's partial sum looks like a random huge interaction, 42949673331. That means nothing on its own. Phase 4, in the results reconstruction phase, we grab everyone's partial sum 50, 35, 120 and 201. We add them all up, take the modulo 2 power 32 and beautifully land exactly on our grand total 414. The verification checks out and that proves our security multi-partly compliance allows us to calculate accurate result over a network without sacrificing privacy. Of the assignment, thank you for watching my video.